Welcome to this explainer. You know, if you're a hobbyist of any kind, you know this exact feeling. You're wandering down the aisles of your local hardware store, you spot something clever, and bam, your brain immediately starts doing the math on how you can use it to upgrade your setup while saving a few bucks. It's the universal temptation of the DIY workaround, right? Well, today, we're looking at a really fascinating piece of documentation from a hobbyist named Ang. Ang actually chronicles their aquatic adventures in an ongoing series called Notes on Fishkeeping. We're zooming in on part 2084 of these notes, which tackles a very specific, but honestly highly relatable temptation, repurposing a cheap, multi-purpose, non-aquarium LED light for a fish tank.
Okay, let's dive into this. The central question here is as simple as it is absolutely vital. Can multi-purpose LED lights actually work for aquariums? Like, is grabbing a basic camping or emergency light off the shelf a brilliant money-saving hack? Or is it just a massive disaster waiting to happen? We're going to use Ang's meticulous breakdown to find out exactly what happens when you introduce general-purpose hardware into a highly specialized aquatic environment. So let's start with the setup, looking at Section 1, the DIY lighting temptation.
As Ang describes it, the whole thought process begins right there in the hardware store. You're looking at different types of LED lighting, and a multi-purpose LED light, the exact kind you'd buy for a camping trip or shove in a closet for a power outage, it just catches your eye. And the appeal is incredibly obvious. These lights are super bright, they're usually dirt cheap, and they look like they could easily just rest right on top of a tank. This perfectly sets up the expectation side of our narrative. You're fully expecting to get bright, efficient lighting for literally a fraction of the cost of specialized aquarium gear.
But let's look at the reality of the situation in Section 2, 4 critical lighting hazards.
Here, Ang completely pulls back the curtain on why this tempting little DIY hack is actually a huge problem. You see, an aquarium isn't just a box of water. It's a complex, highly demanding microenvironment. And based on Ang's research, this multi-purpose LED light fails to meet the basic needs of that environment in 4 very specific ways. First, there's a complete lack of waterproofing. Second, it has the wrong light spectrum. Third, a lack of heat dissipation. And fourth, it's highly susceptible to corrosion. So let's break these down and see exactly why general hardware fails so spectacularly in this context. Now, what's really fascinating here is how using the wrong light actually fuels your tank's absolute worst enemy. You might be thinking, hey, light is light, but aquatic plants actually require highly specific spectrums to photosynthesize effectively. These multi-purpose camping LEDs, they're designed for human visibility, not for delicate plant growth. So what actually happens? Well, Ang points out that using this improper light spectrum completely bypasses the needs of your aquatic plants and instead heavily promotes algae growth. You're essentially building a dedicated life support system for algae to just take over your entire aquascape. On top of that, we have to consider the physical environment the light is subjected to, alongside the physical output of the light itself. Think about it. Camping lights don't typically have heavy-duty heat sinks because they're meant to be used out in the open air. If you plop one over a fish tank, that lack of heat dissipation means the heat has literally nowhere to go but down. That directly raises the water temperature of your tank, which can severely stress out your fish. At the same time, the tank is constantly evaporating water. This creates a relentless high-humidity environment that attacks the unsealed metal components of the light, leading to really rapid corrosion. It's a vicious cycle. The tank breaks down the light, and the light degrades the tank's environment. But here's the thing. The most absolutely crucial point in this entire setup is safety. While algae blooms and temperature spikes are terrible for the health of your tank, Ang identifies the absolute primary concern as the complete lack of waterproofing. I mean, these emergency lights are simply not built to be dropped in water or constantly splashed. Suspending an unsealed, actively powered electrical device directly over a body of water, that is a massive, undeniable electrical safety hazard. It's the ultimate deal breaker here. Let's shift our perspective a bit and look at Section 3, Lessons from Past Tanks. This actually brings up a really interesting moment of reflection in Ang's notes. Is all non-aquarium DIY lighting just inherently doomed to fail? Well, not necessarily. Ang contrasts this current failure of the unsealed camping light with past successes. Quoting here, many moons ago, Ang successfully used typical T5 and T8 LEDs over aquariums with surprisingly good results, noting that the major issues like that rapid corrosion and those scary electrical hazards didn't actually materialize. And this just brilliantly illustrates how DIY isn't always bad, right? But the physical properties of the hardware completely dictate your success or failure. Why on earth did the T5 and T8 LEDs work while the camping light failed so miserably?
Because, as Eng notes, those older lights were tightly sealed. Context matters immensely here. That tight seal protected all the internal electrical components from the high-humidity aquatic environment and the splashing water. It shows us that if a piece of hardware can conquer that primary hurdle, waterproofing and safety, the other variables might actually be manageable. But spoiler alert, the camping light simply does not have that seal.
All right, let's move on to section 4, the final verdict, and see how this all wraps up. This is exactly where Eng's practical, budget-conscious evaluation lands. We've weighed the temptation of saving a few dollars against the harsh realities of algae blooms, overheating, corrosion, and, most importantly, serious electrical hazards. And Eng reaches a very logical conclusion. Given the affordability of dedicated aquarium LED lighting, I might as well get the right lights for my tank. The landscape of the hobby has fundamentally changed over the years. Dedicated, safe equipment is no longer prohibitively expensive, which honestly entirely nullifies that original temptation to cut corners with hardware store alternatives. So it really all comes down to picking the right tool for the job. Ang's journey through those hardware store aisles is a fantastic reminder for all of us. When you're dealing with specialized environments, especially, and I mean especially when electricity and water are mixing, the risks of a cheap hack almost never outweigh the benefits of using purpose-built equipment. So I want to leave you with this to consider for your own future projects. When safety is completely on the line in a humid environment, is the DIY workaround really worth the risk? Thank you so much for joining me for this explainer. Keep learning, and I will see you next time.